Today we are going to discuss some important concepts and limits which are related to grade 11 as well as grade 12 because in grade 12 we have fifth chapter called continuity and differentiability. In the concept of continuity, we have to find limits of functions because when limit of the function exists, then only it is said to be a continuous function, otherwise it is a discontinuous function. So in order to understand the concepts of grade 12, we need to understand limit of this function clearly in grade 11. Now for that, we have few set of important problems given in this module so that we are going to discuss them. All right. Now coming to the very first problem, evaluate limit extends to 2 f of x, where how this function f of x is defined: x cube plus x square minus 16x plus 20 divided by x minus 2 whole square when x is not equal to 2 is equal to k when x is equal to 2. What does the meaning of this particular function? You first find out limit of this function. That function value is equal to k. It means you have to find out the value of k. So whenever you find out limit of a function, the very first thing that you have to do is substitute the value of x is equal to 2 in x cube plus x square minus 16x plus 20 by x minus 2 whole square. See, substitution is nothing but when you are going to check whether left hand limit and right hand limit both coincide each other or not, then you are not supposed to get an indeterminate form. What do you mean by indeterminate form? Indeterminate form is nothing but which is in the form of 0 by 0 or undefined divided by undefined or undefined power undefined. So these kind of forms are said to be indeterminate forms. So your limit should not give an indeterminate form. Suppose while substituting, if you get any indeterminate form, so what does that mean? You have to change your path. So try to find out the limit of the function in any other way. All right. Now coming to the given problem, limit extends to 2x cube plus x square minus 16x plus 20 whole divided by x minus 2 whole square. This is what is the given problem. Let us first substitute x is equal to 2. Then it is going to be, of course, the denominator is 2 minus 2, 0, 0 square is 0. Coming to the numerator, 2 cube is 8 plus 2 square is 4, 8 plus 4 is equal to 12. 12 plus 20 is equal to 32 minus 16 2s are 32. So 0 divided by 0. So 0 by 0 means what? It is an indeterminate form. Therefore, what are we supposed to do? We have to change our way. Since the numerator is a polynomial function, of course the denominator also, but you have to understand one thing. When you substitute x is equal to 2 in the numerator, what do you get? You are getting 0. So when you get 0, when you substitute x is equal to 2 in the numerator, what does that mean? X is equal to 2 is a root of this cubic equation, or x is equal to 2 is 0 of this cubic polynomial. So when you know 1 0 of a cubic polynomial, again x minus 2 whole square, 2 times x can be 0 here. So 2 times the polynomial can be 0 for the value of x is equal to 2. So you have to understand one thing, that numerator is exactly divisible by x minus 2 whole square. Since numerator is a third degree polynomial, therefore x minus 2 whole square is a second degree polynomial. It means you will get one more factor for the numerator other than x minus 2. So let us try to find out what is that one more polynomial. For that, you have few set of methods to find out the factors. Now I will tell you one easiest way, that is what called Horner's method of synthetic division. So what is that Horner's method of synthetic division? Let me explain that. Now this is a third degree polynomial, right? Write all the coefficients without fail. So coefficient of x cube is 1. Coefficient of x square is also 1. Coefficient of minus 16x is minus 16. And then coefficient of x power 0 is 20. Right? We have written all the coefficients without fail. And then in this method, you put 0 below the first coefficient. Since x minus 2 is a factor, so x is equal to 2 is a 0, right? Now just do one simple thing, that add 1 and 0. 1 plus 0 is equal to 1. Now multiply 1 and 2. 1 times 2 is equal to 2. You repeat the process till the last number, right? So 1 plus 2 is equal to 3. Multiply 3 and 2 is equal to 6. Again add these two. Minus 16 plus 6 is equal to minus 10. Again multiply these two. Minus 20. Again add these two, you get 0. You know why did you get 0? This place is the reminder's place. It means when this polynomial is divided by x minus 2, it leaves the remainder 0. Right? Again, we have one more x minus 2 also. No? Repeat the same process. Put 0 below the first coefficient and then write x is equal to 2. Same thing, 1 plus 0 is equal to 1. 1 into 2 is equal to 2. 3 plus 2 is equal to 5. 5 into 2 is equal to 10. Minus 10 plus 10 is 0. Right? You get the remainder 0. Now, x minus 2 is 0. So, x minus 2, x equal to 2 is 0. X minus 2 is a factor. And then x is equal to 2, again one more 0. So, one more factor is x minus 2. And the third factor is this. So, these two are the coefficients. Since it is a third factor, it means a linear factor. So, that it is going to be 1 into x plus 5. This is about the numerator divided by x minus 2 whole square. Limit x tends to 2. Now, x minus 2 whole square and x minus 2 whole square can be cancelled. Left with 1 into x plus 5, limit x tends to 2. So now happily you can substitute 2 in the place of x. So 1 into x is x only now, that x is equal to 2 plus 5 is going to be 7. So 7 is the value of k. It means the limit of this particular function is 7. Right? So this way we can find out limit of the function. And coming to the next problem. See what is the next problem given here. Coming to the next problem. Once observe this. This is limit x tends to p root x plus p minus root 2p divided by x minus p. Again substitute x equal to p here. P plus p is equal to 2p, that is root 2p minus root 2p gets cancelled, will be 0 divided by p minus p equal to 0 is an indeterminate form. So when it is indeterminate form, what are we supposed to do? We have to think about alternate method. Since the numerator involved irrational numbers, so the very first thing that we can do is rationalize the numerator, right? Rationalize the numerator. So how do we rationalize the numerator? Limit x tends to p, root over x plus p minus root 2p divided by x minus p is the given function. When you're rationalizing the numerator, root 2p divided by root over x plus p plus root 2p, because this is what is the rationalizing factor of numerator. Then when you rationalize numerator, always the product should be in the form of a minus b into a plus b, which is going to be a square minus b square. A square means root x plus b whole square is x plus b minus root x minus b whole square is, this is minus 2b whole square. Root over minus 2b whole square is minus 2b. Whole divided by, the denominator remains unchanged, x minus p into root over x plus p plus root 2p, right? Now see, when you simplify the numerator, limit x tends to p, numerator is going to be x plus p minus 2p is going to be x minus p divided by, still we have one more x minus p in the denominator into root over x plus p plus root 2p, right? Again, x minus p gets cancelled. Finally, left with 1 divided by root over x plus p. X is going to be p, right? So it is p plus root 2p, which is equal to 1 divided by root 2p plus root p plus p is root 2p plus root 2p is 2 root 2p. This is what is limit of the function, right? So whenever you come across square roots in your function, in order to find out limit of the function, then first check whether you get indeterminate form or not. If you get indeterminate form, then rationalize the numerator or denominator wherever that irrational number involves. And coming to the next problem. Want to see, this problem is a little interesting because this problem involves what is this trigonometric functions. Here the problem is limit x tends to pi by 4, limit x tends to pi by 4, root over 2 into cos x minus 1 divided by cot x minus 1, right? Root over 2 into cos x minus 1 by cot x minus 1. Again, if you substitute pi by 4, obviously we will get indeterminate form. Because cos pi by 4 is 1 by root 2. Root 2 1 by root 2 is 1 minus 1 is 0. Cot pi by 4 is equal to 1 minus 1 equal to 0 by 0 indeterminate form. Then what are you supposed to do? If you just observe root 2 cos x minus 1 by cot x minus 1, let us try to simplify this. Okay, later I will apply limit extends to pi by 4. Now my focus is only simplifying this. Root 2 cos x minus 1 divided by cos x can be written as cos x by sin x minus 1. So when you simplify, here you get root 2 cos x minus 1 divided by, when you take LCM, what do you get? Cos x into 1 is cos x minus sin x whole divided by whole divided by sin x will be there now. I am going to send that numerator and then it is going to be into sin x. Now see, root 2 cos x minus 1 by cos x minus 1. Then you just think logically, root 2 cos x minus 1 is a part of cos 2x formula. And cos x minus sin x is a part of cos 2x formula. You know how it is? Once observe, I'm going to write that cos 2x is equal to, you have three formulas for cos 2x, that is cos square x minus sin square x. This is one formula. You can write this cos square x minus sin square x as cos x minus sin x into cos x plus sin x, right? This is cos x minus sin x into cos x plus sin x. This is one formula. See, here it is cos x minus sin x. But in order to get that formula, you need to multiply this by cos x plus sin x. Why to get that formula? Let us see one more formula for cos 2x. That is 2 cos square x minus 1. You can write 2 cos square x minus 1 as 2 can be written as root 2 whole square into cos x whole square is going to be root 2 cos x whole square minus 1 whole square. So this is the form of a square minus b square. It means root 2 cos x plus 1 into root 2 cos x minus 1. See, root 2 cos x minus 1 is there. So that is why in order to get cos 2x formula, you have already root 2 cos x minus 1. So multiply by root 2 cos x plus 1. Similarly, cos x minus sin x should be multiplied by cos x plus sin x in order to get that formula. Now, our problem is going to be, I am taking root 2 cos x minus 1 first into, I multiply by root 2 cos x plus 1 divided by root 2 cos x plus 1, right? This numerator is over. Coming to the denominator, cos x minus sin x, no? So 1 divided by cos x minus sin x. In order to get that formula, I multiply by cos x plus sin x divided by cos x plus sin x. Hope you understand this. And left with only sin x, no? So into sin x. And now root 2 cos x minus 1 into root 2 cos x plus 1 is 2 cos square x minus 1. That is going to be cos 2x. All right. Whole divided by, what is this? Root 2 cos x plus 1. That is the first one into, see the second one. Numerator cos x plus sin x remains same, cos x plus sin x. But coming to the denominator, cos x minus sin x into cos x plus sin x is going to be cos 2x. So it is cos 2x into, left with one more sin x. Now cos 2x gets cancelled. Left with cos x plus sin x into sin x by root 2 cos x plus 1. Now we are going to apply limit x tends to pi by 4. Substitute x is equal to pi by 4 here. Cos pi by 4 plus sin pi by 4, right? Cos pi by 4 plus sin pi by 4 into sin x is nothing but sin pi by 4 whole divided by, left with root 2 cos x plus 1, right? So root 2 cos x is pi by 4 plus 1. Now when you simplify this, cos pi by 4 is equal to 1 by root 2 plus 1 by root 2. 1 by root 2 plus 1 by root 2 is going to be 2 by root 2 into cos pi by 4 is equal to 1 by root 2. Whole divided by root 2 into cos pi by 4 is equal to 1 into 1 plus 1. So finally what do you get? 2 divided by root 2 into root 2 is equal to 2. 2 by 2 is equal to 1 divided by, this is root 2 into cos pi by 4. Cos pi by 4 is 1 by root 2, right? So 1 by root 2, 1 by root 2, 1 by root 2. This root 2 root 2 is cancelled. 1 plus 1 is equal to 2. Finally, you get, which is 1 divided by 2. All right. So this way you can answer this kind of problems. Coming to the next problem, which is fourth problem. Once you observe this fourth problem is defined something else. So f of x is given as 1 minus cos 4x by x square when x less than 0 and root x divided by root over 16 plus root x minus 4 when x greater than 0. Evaluate limit x tends to 0 minus f of x. Let us first find out limit x tends to 0 minus f of x. What do you mean by 0 minus? 0 minus f of x is limit x less than 0. Means you have to consider this condition. That is, limit x tends to 0. What is this condition? 1 minus cos 4x divided by x square. You know, when you substitute 0 in the place of x, it will become 0. By 0 is equal to indeterminate form. So now you have to think about it. See, this is 1 minus cos 4x, right? You have cos 2x formulas. What is cos 2x? Cos 2x equal to 1 minus 2 sine square x. This is one formula, right? Then how can I get the formula for cos 4x? Cos 4x can be written as cos of 2 into 2x, right? Now this is in the form of cos 2x, 1 minus 2 sine square x. This is cos 4x is cos of 2 times 2x. It means when you compare this one and this one, what do you observe? Here 2x and here it is 2x is in a bracket. So 2 is outside, means 2x should be substituted in the place of x, right? So then it is going to be 1 minus 2 sine square. In the place of x, you write 2x. This is what is the formula for cos 2x. Substitute the formula, then it is going to be limit x tends to 0. 1 minus cos 4x is equal to 1 minus 2 sine square 2x whole divided by x square is x. So, which is equal to limit x tends to 0, 1 minus 1 minus of minus plus 2 sine square 2x whole divided by x square. So, minus 1 and plus 1 gets cancelled. Left with 2 sine square 2x divided by x square. So, let us take the 2 outside and then limit x tends to 0. This is sine square 2x is sine 2x by x whole square. May I write like this? Because you have a formula that limit x tends to 0, sine kx divided by kx is equal to 1. Okay, you already derived this. So that limit x tends to 0, sine 2x by 2x should be there now. How do you get the 2x? So it is understood that multiply by 2 and divided by 2. Alright, then it is going to be 2 into limit x tends to 0. 2 square is equal to 4 into sine 2x divided by 2x whole square, right? So 4 into 2 is equal to 8 into limit x tends to 0, sine kx by kx is equal to 1 square is equal to 1, which is equal to 8. This is what left hand limit of this function, correct? And coming to the right hand limit, what is right hand limit? Root x divided by root over 16 plus root x minus 4. Okay, I'm going to find out right hand limit of the function. So when I find right hand limit of the function, so what am I supposed to do? All right, so here I'm going to erase small part of this problem because I'm going to find what is right hand limit of the function. So coming to right hand limit of the function, what is the given function here? See, left hand limit you got 8. Coming to right hand limit of the function, all right, limit x tends to now 0 plus f of x. Okay, limit x tends to 0 plus f of x dx. That is going to be limit x tends to 0. 0 plus means x greater than 0. That is root x divided by root over 16 plus root x minus 4. Again, you rationalize the denominator because it is involving square roots. That is 16 plus square root x minus 4 divided by root over 16 plus square root x. This is minus 4, right? So plus 4 divided by plus 4. So when you multiply numerator terms, limit x tends to 0. This is root x times root over 16 plus root x plus 4 divided by root over 16 plus root x minus 4 into root over 16 plus root x plus 4 is again in the form of a plus b into a minus b, which is going to be a square minus b square. So a square means root 16 plus root x whole square is 16 plus root x minus 4 square is equal to 16. Now 16 and 16 gets cancelled. Later, root x divided by root x will also get cancelled. So denominator left with 1. Directly you can substitute x tends to 0 here. Root over 16 plus root 0 plus 4 divided by 1, which is going to be how much? Root 16 is equal to 4 plus 4 is equal to 8. You remember left hand limit also we got 8. 8 is equal to 8. So therefore, what does that mean? Check whether limit extends to 0 f of x exists or not. Yes, it exists and the value is going to be 8. Therefore, the value of a is equal to how much? The value of a is equal to 8. So this way we can find out limit of the function. So coming to the next problem, see, this is one of the most important problems, where the problem given here is limit extends to 0 minus modulus of x divided by x, and the limit extends to 0 plus modulus of x divided by x, and verify limit extends to 0 f of x exists or not. It is very easy when you know what is the definition of modulus of x. See, modulus of x is equal to positive x when x greater than or equal to 0. Similarly, is equal to negative x when x less than 0. We already discussed about this. We learned this. So depending on this, you can find out what is left hand limit. Left hand limit is nothing but limit extends to 0 minus f of x. What is that? Limit extends to 0 minus means less than 0. Less than 0 means what? This one. Modulus of x divided by x, which is equal to limit extends to 0. Now, when x is 0 minus, what is modulus of x? 0 minus means x less than 0. Then modulus of x is going to be minus x divided by x. Minus x by x is equal to minus 1, right? So limit extends to 0 minus 1. What is limit extends to 0 minus 1? Yes, it is minus 1 because there is no x to substitute. Similarly, what is right hand limit of the function? That is limit extends to 0 plus f of x, which is equal to limit extends to 0 plus f of x is modulus of x divided by x. Now limit extends to 0. Now see, 0 plus is nothing but greater than 0. Modulus of x equal to positive x divided by x. X by x is equal to 1, right? It means limit extends to 0, 1, which is equal to 1. Now you observe limit extends to 0 minus f of x is not equal to limit extends to 0 plus f of x. What does that mean? Limit does not exist. Okay. So this way we can answer the problems. Right. So in the next module, we'll discuss few more set of problems. Right. Hope you understand. Thank you.
Subscribe.